So we are going to answer questions on the periodic table. That is chemistry. So the topic we are looking at in terms of questions is called the periodic table. So we're going to answer various questions coming from various years. These are ECZ exam questions. Okay. So the first question that we are answering is this one. Below is a skeleton diagram. This one's supposed to be a skeleton diagram of the periodic table. So as you can see, the skeleton diagram, just for you, maybe just to indicate here, this is group 1, 2, that is group 3, and of course that is group 8. Okay, just to indicate the group numbers. All right. So what is the first question here? So the first question is, give the name of the region marked X on the periodic table. Give the name of the period marked X on the periodic table. Okay, so here we are going to write transition metals, but also at an advanced level, this one is called the F block. I don't know if it's covered at ordinary level. It might be something that is beyond our scope, but of course it is also called F block. Then give two general properties of element found in the region marked X. So what is the general property of the elements found in the region marked X? So now these are metals, as the name suggests, transition metals. These are metals. So now the general function, that is question B, give N2 general properties of elements found in the region marked X. So what are the general properties? What do they have in common? So they conduct heat and electricity. They are metals, so they conduct heat and electricity. They have high melting point. So they have high melting point. Okay, so these are some of the general properties of the metals that we find here. We can also add they form positive ion. They form positive ions, which means they lose electrons. They are metal. These are general properties or characteristics of metals. Okay, so these are the ones that we can look at, but of course also contribute your own as you go through the recording. We are up to question C. State any two uses of element found in the region marked X. So what are the uses? So here we can be specific. Copper is used in making electric cables. So copper is used in making electric cables. Zinc is used in making roofing sheets. So zinc is used in making roofing sheet. You can talk of also iron that is used in building bridges and all that. So quite a number of uses that you can talk of if we are to pick each of the element and of course give its function. Of course you can look at also mercury, which is used in thermometers. Okay, so these are some of the uses that we can look at in terms of elements that are found in region X if we are to be specific. So we've answered this question fully, and now we can move to the second question. Okay, so this question, the grid below represent part of the periodic table. Study it and answer the questions using the letters. The letters are not the actual symbol of elements. Okay, so here is the diagram, I mean the grid that we have. So A question, an element V has atomic number of 7. So on the periodic table, what you know that if there's an element X, the number on top here is the mass number, and of course this is the atomic number. And one thing you should know is that the atomic number is the one that is used to assign configuration. So we are told that element V has the atomic number 7. Indicate the position of V on the grid. Indicate the position of V on the grid. So how do we indicate the position? How do we indicate the position of V on the grid? We need to know the period where it belongs and of course the group. Now, how do you know the group? The group, if we are to write the configuration, this one is 7 atomic number. So the configuration, you know that in the first shell, there are 2 electrons. So 2. Then of course the remaining 5 outside. So which means in terms of group, or let me start with the period, you just count number of shells. So in the first shell, there are 2 electrons and the second shell there are 5. So in addition, I mean to add them, there are 2 shells. So this one is in period 2. Then in terms of a group, you just look at the number of electrons in the outermost shell. So this is in group 5. So how are you going to move to identify the parts where this one is going to be? So you're going to count the period. This is period 1, 2, 3, 4, 5. So it is in period what? 2. So you're going to follow it, period 2. You can draw a line there, a faint line. Then group 5. So you count the groups. 1, 2, 3, 4, 5. It's in group 5. So you put a line like there. Where they intersect, that is where you find V. So V will be right here. So we've indicated where V is. Explain why the atomic radius of E is bigger than that of R. Now here, something that you need to understand is what is the atomic radius. So now, if you have an atom, let's say an atom with shells, the atomic radius is just a distance from the center of an atom to the outermost shell. This is what we call atomic radius. Okay? So now, in terms of atomic radius, as you move, you know that elements, the other thing that I should explain is that elements that are found in the same period, they have equal number of shells. Okay, so those that are found in the same period have equal number of shells. But of course, the number of electrons in the outermost shell differs. For example, what I'm trying to say is that lithium is in group 1 and of course period 2. So lithium has atomic number of 3, which means we have 2 in the first shell and of course 1 in the second shell. But the other one, beryllium, which is in the same period with lithium, the atomic number, let me just write, the atomic number for beryllium is 4. So the number of electrons in the outermost shell is 2. Then of course in the second one is 2. This one we can extend it to boron, which is just B, with atomic number of 5. The first shell has 2, and of course the second one has 3. Now look at these. They all belong. So this is where you find boron, and this is where you find beryllium. They are all in the same period because they have equal number of shells. Look at 2 number of shells, 2 number of shells, 2 number of shells. So here you can conclude that elements that are found in the same period have equal number of shells, but different groups. Groups are determined by the number of electrons in the outermost shell. For example, this one, the outermost shell has 1, so it belongs to group 1. This one, group 2. This one, group 3. Okay, that is something that you should know. Now, how do we relate this one to the atomic radius? So the way it is, since the number of shells are the same, but the nuclear positivity is increasing. You know that protons are the one that makes up the nucleus and the neutron. Neutrons are neutral, but protons are positive. Okay, so the positivity of the nucleus is increasing, okay, but the number of shells remains the same. So when the positivity of the nucleus is increasing, there's an increase also in the force that pulls electrons toward the center. So in terms of in terms of atomic radius, as you move from this side going to this side, the atomic radius continue to decrease. Okay, the atomic radius continue, or the size of an atom continue to shrink, and that is just due to what I've explained. So electropositivity, or the positive charge of the nucleus, increases, hence pulling the electrons toward the nucleus. Okay, so for question B, Explain why the atomic radius of E is bigger than that of R. So how do you answer such a question? So with what I've explained, you can just simply say because E has less positive nucleus compared to R. Okay? Because E has less positivity in the nuclear compared to R. Okay, it's a 1 mark. So please, how would you express this answer if were you? Okay, if it was you answering this question, how do you answer it? So let me hear from you as well on this part. Now for question C, which element has the highest tendency to gain electrons? Now listen to this. The trend, if we look at the trend across the period, the progression, as you move from this side going that side, 1, electronegativity increases. Okay? Electronegativity increases. Now what is electronegativity? Electronegativity is just a tendency of electron or elements to gain electrons. Okay, atoms of element to gain electrons. As you know, you are moving from metals to non-metals. Metals have a tendency to lose electrons. Then of course, non-metals, they gain electrons. So as you follow them, there's a high chance of the elements are gaining electrons. So which one has the highest tendency? So the one with the highest tendency again here, if we are to compare, because you have non-metals, okay? This one is the non-metal, this one is the non-metal, this one is the non-metal. So now, since we are saying going this side is going to increase, and the last one that we have here is this group. So this is where you find the one with the highest tendency to gain electrons. Now, which one do you pick of the 3? You need to understand that for non-metals, electronegativity has to do with reactivity also. So electronegativity is connected to reactivity series. Now for non-metals, the most reactive, in short, as you go up, reactivity increases, which means the most reactive is this one on top, and of course at the bottom here is less reactive, and therefore this one has the highest tendency to gain electrons. I guess you've gotten that. So the one with the highest tendency is the R. Then they are saying select the most reactive metal. Now what I've just explained is the opposite to metals. We said as we go up, the reactivity of non-metal increases, which means the most reactive is the one on top, and the less reactive is the one at the bottom. But for metals, it's different. As you go down, electronegativity increases. So which means the most reactive is this one at the bottom, and therefore the most reactive metal is C. Write the formula of compound formed when B react with the E. So here, do not act clever and of course identify what B and E is. You can just use the symbol given. So B react with the E. What is going to form? Now you know that when you are writing chemical equation, you need the valences. So how do you identify the valences? Just on the periodic table. So the group number of an element, if they are metals, that is its valence. So for example, B is from group 1, so its valence is 1. But for non-metals, you always subtract 8 minus the group number. Where is E found? So this is group 1, this is group 2, group 3, group 4, group 5, group 6. So it's found in group 6. So to find its valence, we say 8 minus 6. And this is 2. So the valence of this one is a 2. Then we swap these. We are going to have B2E. So that is the formula of the compound formed. So I'm sure we are just interested in this part. Okay, so the formula for the compound formed is B2E. I guess you've gotten that. Up to the other question here that we have. So for this question, B4.1 below shows element in the periodic table. As you can see, which period of the periodic table do these elements belong, or do these elements belong? The good part about chemistry is that the periodic table you are given, so you just have to go and check. And you need to know that the period is the horizontal row. Okay, so from the left to the right, like for example, this that we have, the grid that we have here, from this side to this side, these are periods. I guess you know what a period is and what a group is. So those are the periods. So here, to which period does this one belong? If you were to check, the only one that is in the first period is hydrogen and helium. So starting lithium, beryllium, and all these going down, they are in period D. I mean, this is period 2. Okay? So on the periodic table, the way it is, the common periodic table that you are going to find, let me just put it like this. I want you to understand something. So if this is the periodic table grid that looks like this, there's always hydrogen here on top, and of course here there's an extension of helium. So this is period 1. Whatever starts down here is period 2, period 3, and all the way to period 7. I guess you've gotten that. Don't make a mistake of starting counting from here as period 1. Okay, that mistake, you might make it. So make sure that you understand very well. So if we were to look at the periodic table, these belong to period 2. Okay, so it belongs to period 2. Now, what happened to the number of shells across the period? So in this case, they are just asking you, what happened to the number of shells across the period? It's the same, it's general. So the number of shells, I think I just explained at some point, remains the same. So the number of shells remains the what? The same across the period. Okay. Then answer the following question using only elements shown in the table. Each element can be used once, more than once, or not at all. Which two elements would form ionic compound? Now, every time you hear of ionic compound, think of a metal and a non-metal. So, starting from here, we are talking of, is this carbon? Starting from here. So, we are talking of non-metals. Okay? Now, which one would form ionic compound? So, for me, I would pick lithium and oxygen, okay, to form lithium what? Oxide. So lithium and oxygen. Or you can put beryllium. So long as you are picking a metal and a non-metal, that is ionic compound. I guess you get that. Which element has the valence of 3? So the one that has a valence of 3 is the one that belongs to group 3, or the one that is in group 3, that is in terms of metals. But in terms of non-metals, is the one that is in group 5. Contain the valence of what? 3. Now, how do you know? So please, this is the period, so which means this is group 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I said the one that is in group 3 is the one that has a valence of 3 here, which is boron. And of course, the one that is in group 5, which is nitrogen. They said you can use 2 or 1. So here we have B and N. They have a valence of 3. Which element has allotropes? Okay? So which element has allotrope? So allotrope, we are just looking at elements of the same, elements of the same, atoms of the same element. In this case, they have, they belong to the same element, but they have different structure and geometric shape. And in this case, the one that has allotrope is carbon, which is helium and which is graphite and diamond. I guess you know that. You might want to check out that part. I have a recording on non-metals where I answered the question on carbon. Okay, so that is where we get to end with that question. So we look at the second, this question. Atoms of element A, B, and C have 8, 17, 20 electrons. So these are electrons. Using the letter, construct the chemical formulae of the compound formed between atoms of A and C. You know that electrons are the ones that we use to write the configuration. So before we write the compound, what we need is the valence. Okay, so A and C. Now looking at A, because here they've said respectively, which means A goes with 8, B goes with 17, C goes with 20. So if we were to write the configuration of A, it is going to be 2 in the first shell. What remains? 6. Then of course the C, we have 2, 8, 8, then of course 2. So that is for C. So the configuration of C is this one. Now the question is that what is the valence of A and what is the valence of B? So now we are not going to identify what A is and what C is. We are just going to use them the way they are. So A has a valence of 2. You remember it's a non-metal, so we just subtract this one minus 8. And how do you know that you need to subtract? If you have the outermost shell, which is 5 and above, just know that you need to subtract 8 minus the number of electrons in the outermost shell to find the valence. That is something that I explained in one of the videos that is on how to write the chemical formulae. You might want to check that one out as well. Then plus C. C as well, the number of electrons in the outermost shell is 2, and that is the metal. So now what is going to form? This swap, and this is just 1 to 1. So it's going to be AC. So using the letter, construct the chemical formulae of a compound formed between atoms of A and C. So it's just AC. Okay? And that is the answer. Element B and C can react to form compound. Name the type of bond formed between B and C. Now C, we know that is a metal. Now what about B? What about B? So for B, if we were to write the configuration, it is 2, 8, and of course 7. So this is a non-metal. Okay, so you have the reaction between a non-metal and a metal. The kind of reaction or the kind of compound formed is called ionic compound. Okay, so name the type of a bond. Okay, the question is name the type of bond. So it's ionic bond. Okay, ionic bond. State one physical property of this compound. So in other words, you are just stating the physical property of ionic compound. Okay, so they have high melting and boiling point. So high melting and boiling point, that is one of the physical property. You can talk of other physical properties such as high density. Okay, then draw the electronic structure if the product formed when, or draw the electronic structure if the product formed when, this one should be of the product formed when atoms of A combined. So atoms of A combine. Write or draw the electronic structure. So A, just A, which is this one, which is the non-metal. So we're just going to look at the outermost shell. Okay, so we're going to put it here. Okay, like this. You know that has the valence of 2. So which means they are going to form a double bond in the middle. So they are going to share. This one contribute an electron and also this one. This one and also this one. Then of course what remains here, what remains is 2, 2, 2, 2. Okay, this is A and this is the A. So I've just shown the outer shell. Okay, so that is how it is going to be. Give one industrial use of element A. This is oxygen. Okay, this is oxygen. Now one industrial use, it is used in welding. Used in welding. So when you are given industrial use, it is not medical use or maybe some other use. You need to stick strictly to industrial use. So it is used in welding. Okay, so you can give some of the use at industrial level that you think. So I've given you the space that is remaining here. You can put some uses. Just type in the comment section. We appreciate. Okay, so here is another question that we are going to answer. So this one, reads, the following diagram shows element coded with letters Q to Y, which do not represent the actual symbol of any of the element in the periodic table. You will need to use these letters in some of your answers. Okay, so as you can see, which element forms, or which element shown, 1, forms an ion with a single negative charge. So the one that forms a negative charge, automatically you think of a non-metal. Then of course, if they tell you a single, which means just a 1, negative 1, which means it gains 1 electron. Now, if it gains 1 electron, you know that in the outermost shell it has 7. And looking at the group, this is group 7. So you are looking for the element that is found in what? Group 7. So the one that forms an ion with a single negative charge is W and X. Is it W and X? Yes, because this belongs to group 7. If we are to count 1, 2, 3, 4, 5, 6, 7. You do not count this. This is just the transition. Okay, so group 3 continues here. I guess you know that. Has 3 electrons in the outermost shell. So if it has 3 electrons in the outermost shell, which means it belongs to group 3. And of course, if it's a non-metal, it belongs to group 5. So group 5, there's nothing. So we have group 3, which is just a V. How many protons does an atom of element Y contain? How many protons? So Y, like I said, in the first period, you have this, which is hydrogen. And of course, you have, which is helium. So helium only has 2. So it has 2 protons. Something that you need to know. State the element which is the most reactive metal. So this one is just a repetition of what we've answered. Most reactive metal, we said as you go down, reactivity increases. And the one at the bottom is the most reactive. So we are putting T. Then most reactive non-metals. As you go up, reactivity increases. So group 8, they are non-reactive. So we are not going to consider that. And this is not part of okay, so we are dealing with this group. So the one on top here is the one which is most reactive. So W. Deduce the formula of the compound formed between element U and V. I mean W. Between element U and W. Now to deduce is just to form. Like the question that we've answered, just that this time around they've used the term deduce. So now, U react with the W. We look at the valences. What is the valence of U? Now, valence of U is a metal that is in group 2. So it has a valence of 2. Then W is a non-metal that is in group 7. What did we say? 8 minus 7. Valence of 1. So this one has a valence of 1. Now, if we are to cross, we are going to have U, W. So this is the formula of the elements. But some of you are going to act clever and of course identify these. I don't think you need to identify them. Instead, you can utilize or use the letters given. Okay. Let us have a look at this question. The following elements with their configuration, electronic configuration are, the following elements with their electronic configuration are in a certain group of the periodic table, as you can see. So we have W, which has only 2, X, which has only 8, this one 8, 8. Now, just by looking at this, you will see something, and that is the stability. They are all stable because 8 represent stability in the outermost shell if that the number of shell are more than 1. Okay, 2 represent stability if only 1 shell, like in this one. Okay, so only 1 shell, 2 is stable. 2 shells, 8 is stable. 8 is stable. 8 is stable. 8 stable. So these, there are only one, or there's only one group on the periodic table. Now, there's only one group on the periodic table where you find stable elements, and that is group 8. And the group 8 elements have a special name. They are called noble gases, inert gases, or zero group. So the first question here, name the group in which these elements belong. So these belong to group 8. Okay, group 8 written as this. Okay, what account for the chemical unreactivity of this group of elements? So in other words, these elements, they are unreactive. Now what accounts for that? For a reaction to occur, they need to have a valence. Now for these, they are stable. Okay, so what account for their unreactivity? You can say they have stable outermost shell. Okay, or you can say their outermost shell are fully occupied. W is used in weather balloons. Explain why W is most suitable for this. So W is helium because it's the first one in the group. So it is used in air balloons. And this is the reason why it is used in air balloon, because it's lighter than, because W is less dense than air, or can say it's lighter than air. Describe the change in density as you go down the group. So as you go down the group, the density, you can say density increases going down the group. So you need to know how, or the change in physical properties as you go down the what? The group. Okay, here is another question. An element M is in group 1 and period 3. So element M is in group 1. Now group 1, it means that it has 1 electron in the outermost shell. That is in terms of groups. But group period 3, it means it has 3 shells. So it means the electron configuration is 2, 8 and 1. That is what it means. Then element N is in group 6. So N is in group 6 and period 2. So group 6, which means in the outermost shell it has 6 and of course 2 shells. So 2, 6. Okay, so we have these elements. It's very important that I write these because it's going to help me answering the question. The first question is draw dot and cross diagram to show the bonding in compound form between element M and N. Use letters M and N and show outer shell only. So now we are dealing with a metal and a non-metal. This one needs how many electrons? 2 for it to be stable, because this is 6. It needs 2. This one is going to lose 1. So 2 of M are going to combine with the N. So now using cross and dot, okay, we are drawing what? Draw dot and cross diagram to show this. So what is going to happen here? We are going to have, since this is ionic bonding, so we are going to have M, okay, outermost shell. Okay, let me just write the outermost shell, which is M. So outermost shell is going to remain 8. So I'm going to use X for this one. Okay, I'm going to use cross for this one. Okay, then I'll put it in these brackets with a positive charge. In the middle, there will be, let me put, this is the M, this is N. So now for this one, I'll use, since it's different, I'll use dots. Okay, so I'll use dots. Since it has 6, I'll put dots like that. Then of course I'll put negative. Then another N here, another M, because this need 2 electrons, so we need 2 of M, yeah. So it's going to draw M, okay, another M, just like the first one. Then now to this, so positive, it has received 2 electrons, okay, one from here, one from that. So to show them, I'm going to put a cross and also a cross from here. Then you can put these lines like that. I guess that is what we needed to write. So I've shown or we've answered this first question. Then what type of bonding exists in the compound? So it is ionic bonding. If the compound formed is soluble in water, describe what you would do to show whether it is acidic or basic. Your answer should include expected results. If the compound formed is soluble in water, describe what you would do to show whether it is acidic or basic. Your answer should include expected results. So this is the last question. Normally I leave one question for you to answer. So this is the question that you are going to answer, and of course get to share answers with us so that we also can learn from you. So thank you very much for staying up to this point. Okay, so please, if you've not subscribed to my YouTube channel, kindly do that. Don't forget to share to as many friends as possible, okay, so that we can help a lot in terms of revision. Okay, so if you're writing exams next year, that is under IGCSE, Cambridge, and also GCSE, GCE, so please, we are enrolling for next year, that is 2025 online lessons. Get to join us, and of course let us begin this journey together. Otherwise we can end here, and what I can say is that see you in the next one.